Okay, year 10. I wanted to do a screencast here just to summarise some of the statistical things we've been doing on the back of the self-directed task, and I've marked those, so I've got a little idea as to where your strengths and weaknesses lie. So just a few notes around this. Obviously, I'm not around for the next few days, so I'd like you to have some sort of guidance here, and I'll leave you to the work requirements, and you can contact me by email, and I can help you out that way. But just hopefully this will be of some use to you. Yeah, so it's going to be, I'm just going to race through some things that you need to make sure you know. And we talked right at the top, and it came up in your self-directed task, what types of data there are. You know, what are the different categories, and they really fall to two categories. One is categorical, and one is numerical. So numerical, if I could just spell that correctly, that'd be great. Numerical. So data is either numbers, numerical, and that's fairly obvious. If your data's numbers, it's a numerical data. If it's sort of colors or brands or months, it's in here, it's categorical. Now, splitting this numerical down further, there are two types of numerical data, and they are either discrete or continuous. Not as obvious, but discrete are basically discrete numerical data is a bit like, I like to think of this in terms of when you go for a new pair of shoes. Everyone fits into a discrete shoe size. That is, you can be size 6, 6.5, 7, 7.5, 8, 8.5, that sort of thing. That's discrete. These are standalone numbers. There's nothing in between the 6 and the 6.5, if you know what I mean, in terms of shoe size. But continuous, it can be anywhere. Continuous data can be anywhere on a continuum. So between 6 and 7, there's an infinite number of possibilities within those two, because it's continuous. For discrete, there's only between 6 and 7. There's 6 and 7, but nothing in between. Or if we're talking shoe size, 6.5, but they're discrete numbers. So these are the differences between discrete and continuous numerical data. Okay, this is going to appear quite random, but these are just some thoughts. Just make sure you understand that this, when you look up on the calculator, and I'll show you in a moment some calculations, this refers to the mean. And when we're talking about the mean, if you want to, it's not correct to say average. The average is not the mean. So the average actually refers to average. The average refers to either mean. So mean is an average, median's an average. So an average is just a central tendency, a measurement of central tendency. Mean, median, mode, they're all averages in terms of statistics. So if you want to talk about the sum of the scores divided by how many scores there are, then refer to the mean, not the average. If you want to talk about the middle score, talk about the median. But the one that leads to the confusion is this one here, average. In general parlance, in just in the community, people refer, when they say average, what they mean is mean. But it's not, mean is not used in general language. But when we're doing mathematics and statistics, you need to be specific. You can't say average, because that could mean any one of those three. And in your self-directed task, some of you used average to your cost. So that hopefully clears that up. I'd like to refer to the interquartile range, the IQR, the interquartile range. Now, how to find the interquartile range? If you've got 1, 2, 3, 4, 5, 6, 7, let's say 8 scores, even number of scores. You want to split this up into quartiles. This is how you do it. 1, 2, 3, 4. You split, if there's an even number of scores, you split it so there's an even number of scores either side. So if there's 8 scores, I'm going right down the middle. I've got 4 left and 4 right. These two scores here will make up my Q2, which is my median. Right? Q2 and median are the same. Okay, so that's right. But in this lower half of scores, the median of the lower half, which are those two scores there, make up my Q1. Okay, those two added together and divided by 2 would give me my Q1, and these two scores here added together and divided by 2 would give me my Q3. Now my IQR is simply Q3 minus Q1. That's my IQR. Alright, so that's an even number of scores. If there's an odd number of scores, so let's now look at 1, 2, 3, 4, 5, 6, 7 scores. How do we find the Q1, 2, and 3? Well, you know how to find the median. You've done that lots of times. With an odd number of scores, it's just this score here, isn't it? It's that one there. So that is my Q2. That's my median. And what I do is I just rule that out. Right? Now I've got 3 below it and 3 above it. I find the median of the lower half, and that's my Q2. My median of the upper half is my Q3. And so there's my quartiles, and Q3 minus Q1 is equal to my IQR. So that's how to figure out your IQR. Okay, what about... All right, now when it comes to the 5-number summary, this gets referred to a little bit, the 5-number summary. Now the 5-number summary is this. It's, right, 1, lowest score. 2 is Q1, the lower quartile. Right, so for lowest score, Q2 lower quartile, Q1, sorry, lower quartile. 3 is Q2, or the median, as it's generally known. 4 is Q3. Right, this is the 5-number summary. 5 is the highest score. Now, what we do with the 5-number summary is we always make a box plot out of it. So what we do is we find out all these values, and we plot them in a straight line. So what we'll have is just an axis down here with some numbers on it. Okay, this will be numbered up. Okay, they should be evenly put. I'm working quickly, and what I do is I go, right, now if I know what all my numbers are, so I've got my, I'm just looking for a pen, I've got my lowest score, which is here, I've got my Q1, which is here, my Q2 might be quite tight in there, my Q3 might be there, and my highest score is there. I draw them 5 dots in a straight line. What I then do is I do this. I draw a line from my first to my second point. That was a terrible line, by the way. It was a mess. Okay, I've got to replot those points. So I draw a straight line from that point to that point. I then draw a box. I use a ruler, right? And I draw a box around my interquartile range. All right, so this is that's my lowest score there. My Q1 is this value here. That's my Q1. My Q2, I need to draw a little line down the middle of my box. That's my Q2. All right, that's Q2 there. Q3 is at the top end of this box. That's my Q3. And my highest score is here. And I just join those with a line. That's my highest score right there. Now, if there's an outlier as the highest score, what you would do is you wouldn't plot it. So you don't join it with what's called the whisker, or this straight line here. You wouldn't go all the way to an outlying score, because that could be way off the page. So an outlier tends to just sit out there somewhere like that, and you would use the second largest score if it was an outlier at the upper end, and you just join the whisker along to it. So that there is an outlier. Okay, so that's how the 5-number summary links in with the dot plot. One more thing I just want to go through with you, and that is how to use the calculator to make some calculations to do with the R correlation. All right, what's the R correlation? The R correlation tells you, and this came up in your SGT. This is a number between -1 and 1. So R sits between -1 and 1. And it tells you how closely related two variables are. So you remember the one we did with age and distance. They were throwing a discus. The older you were, the further it went, that sort of thing. So the correlation was quite up here. There was a really strong positive relationship. Means that as you get older, you throw it further. If there's a really strong negative relationship, it'll be down this end. It'll be close to -1. That means as you get older, you maybe you don't throw it as far. Then that would be and if it was a really strong relationship, that would be down this way. And if it's sort of in the middle there somewhere, there's not much of a relationship going on at all. And so we can talk about the strength of that relationship. But this R measure, that comes up on the calculator. We'll look at that in a moment. And we also talk about something known as a regression line, or sometimes a least squares regression line. What that is, it's the line of best fit. It's the equation of the line of best fit for your scatter plot. Okay, to make our R correlation calculation, and also to have a look at our regression line, what we do is these are relevant for two variable statistics. So when we are comparing the relationship between two variables, so you know, for instance, I've populated my my spreadsheet here using my my CAS calculator with the data that comes from page 664 of your textbooks, exercise 9H, question 7. So that's in there. Rainfall and growth. Now we'd expect there to be some sort of relationship, wouldn't we, between rainfall and growth. Let's have a little look at what that relationship might be in this case. And in order to do that, we put the data in. If you remember when we just did one variable statistics, we just listed a whole bunch of stuff down here, and we could work out the mean and the Q1, 2, 3, 4, etc. for that. And the IQR and there was a whole bunch of stats. Now, when we're comparing two sets of data, and we want to look at the relationship between them, we go into stats, we go into stat calculations, but now we choose two variable statistics, and we label what we want. So the X list will be what's going to end up on our horizontal axis. That's rainfall. That was what was in our first column, our A column, and growth is going to be in our vertical column. And our results are going to go into column C. That all looks good, and there they are. So as we scroll down here, we can see that you know, the mean of my Y list, which is my B column, mean of the growth, 44.35. We keep going down because what I'm looking for is this R value, 0.92. Remember, the maximum value of that is 1, and that would be perfectly linearly correlated. 0.92 is pretty close. It means that the points line a pretty straight line. All right, so let's have a look at those points. Let's have a look at the scatter graph. How do we find that? Well, we don't go in there. We go back to the main menu. We choose this data and statistics, this little graph page here, and down the bottom we're going to put the rainfall along the horizontal axis, and across the vertical axis we're going to choose growth, and there they go. Look at that. They're in a pretty tight little arrangement, aren't they? And obviously the trend is up, and there are the points there. And we can find, by going through menu and analyze, we can have a look at the regression line as a y. We can choose an mx plus b or an a plus bx. Let's go with the mx plus b. There's the regression line, and there's the equation of it. So by putting in y represents my growth, that's my y-axis. The x represents these values here for rainfall. So we could substitute, you know, rainfall of, you know, something off this scale. Let's say we got 1,000 millimeters. Put 1,000 in here for x. Calculate y. We'd be able to work out from this regression line what the predicted growth is. So that's what we use that's the regression line for, is for predicting and using the points that we've got to make predictions for other data that we don't necessarily have. Okay, so that's all I really wanted to show you, just to help you along, and I'll see you when I return sort of next week, and we're working towards the test on stats on Wednesday. So good luck with the work requirements. Give me an email, shoot me an email if there's anything I can help you with in the meantime. But I'll see you soon. Cheers.